A confirmation about the audio, please, guys. Is the audio clear and available? Thank you. Okay, till now, the portions that we have covered, is that digestible or is it something which is too much? The portions of geomorphology that we have covered. Okay, digestible, midway. Midway also works. Are you able to wrap your head around the imagination that is required, that how is it that the plates could move, how is it or what is it that Wagner actually proposed, why it was incorrect, what is the internal structure of planet Earth? Are you able to wrap your head around it? Abyssal plains, Anjan, are the deep sea plains. At the bottom of the ocean you have flattish plains. We'll study in oceanography as well. Yes, over imagination is required, Weber. Twisha, daylight saving time is, for example, the time zone in India, the standard time is followed with the meridian which passes through the region of Allahabad. Now, in the region of, for example, I'm just giving you an instance. For example, in the region of Arunachal Pradesh, sun will rise much earlier, right? And basically, let's suppose if your working hours are 9 to 6, yeah, and basically you would want to utilize sunlight as much. But what if the sunrise happens at 4 a.m. and sunset there happens at around 4:30 p.m. itself? So that is why you basically wind back the clocks during the summer and move it forward again during the winter in order to adjust for that daylight. That is what is the daylight saving time, the concept of it. Ankush, seafloor spreading is not completely acceptable, but it significantly helped us understand the circulation of the oceanic crust and the oceanic seafloor. Devyani, we had discussed about the format of answer writing with one of the questions about continental drift. Tomorrow, if possible, or when we get to the end of geomorphology, when we shall be discussing all the PYQ. So here, the pattern that we shall be following, guys, is after each of these major units, geomorphology, climatology, oceanography, that is when we'll pick up the bulk questions. Okay, so both prelims and the mains PYQs. So there again, we will talk about it. Yes, Vaibhav, they are the same. Okay. So today, we initiate the discussion from the divergent plate boundaries. And as we initiate the discussion about the divergent plate boundaries, it is a kind of a great coincidence that the region of Iceland, rather, is also in news. And Iceland basically is on top of a divergent plate boundary. How many of you have followed the volcanic eruptions which are occurring in the region of Iceland? Have you followed that? No? So just try to follow it up. In the region of Iceland, there are a series of volcanic eruptions which are happening close to the capital city of Reykjavik. And basically, that is because, and there, if you observe the eruption, the mode of eruption is very different from the normal volcanoes that you would have seen in videos where on top of a conical peak, molten materials emerge. In Iceland, if you get an opportunity even today or tomorrow, I know you have a very busy schedule, so even today or tomorrow when you get time, take a look at the videos of what is happening in Iceland. Now there the method of eruption is very different. A large crack opens up on the ground surface and molten materials, they start emerging upwards. So that is one of the characteristics of the divergent plates. Nonetheless, divergent plates represent what? They basically represent the movement of the plates away from each other. As the plates, they tend to move away from each other. That is what is the divergence of plates. Now, why do they move away from each other? Again, because of the presence of a convection current. because of the presence of convection current underneath. As long as the convection current shall be prevalent, there shall be that away movement of each other. And as a consequence of that, as these plates, they tend to move away, in the gaps, you will have the newer crust, which keeps on getting solidified. Okay, so that is the case of divergence of plates, plates moving away from each other. Now, in this case, we have seen yesterday also with the help of seafloor spreading that whenever there is the movement of land masses away from each other, and let's suppose there is emergence of molten materials, the molten materials will solidify in between. You will have creation of a newer crust, isn't it? Always, and in most of the cases, you will have the creation of a newer crust. And that is why because there is a construction of a newer crust across these plate margins, that is why this is also what is referred to as a constructive plate margin. Constructive plate margin. Now, with the same logic, if I take you back to the convergence of plate. Now, convergent plates, we have seen that in the case where two plates, they collide with each other, one of the heavier one will ideally get subducted underneath the other, or maybe there will be creation of a fold. But in either ways, the boundary of the plate is getting destroyed. It is getting consumed. That is why convergent plate boundaries, they are also what are referred to as boundaries. They are also what are referred to as destructive plate margins. They are known as destructive plate margins. Okay, and divergent plates, where you have a creation of a newer crust, you have the constructive plate margins. Now, where do you observe the divergence of plates? Wherever you have the presence of convection current underneath, in the region of asthenosphere, in the region of lower mantle, that is where divergence is observed. For example, if you observe here, this is your Arabian plate. This is the portion of Arabian plate, and this is your African plate. Now, African plate and Arabian plate were at one point of time, they were joined with each other. But now, over a period of time, there has been a convection current which has come underneath them, and there is a divergence of plates. That is why here across these areas, you will observe the formation of Red Sea. And this divergence further continues into the region of Africa also. Okay, so that is where you have the kind of a divergence. And observe, as the plates are diverging here, as this Arabian plate is moving like this, it is moving almost parallel to the existing plate here in this area. In this area also, it is moving parallel to each other. So where the plates are moving parallel to each other, these boundaries are known as the transform plate boundaries. Okay, so this is the region around Turkey, around the region of Israel, for example. In these areas, Syria, in these areas, you also have the transform plate boundaries. Okay, so that is basically the case of divergence. Now, as the Arabian plate is moving away from the African plate, it is converging with the region of the Asian area. That is the region around Iran. It is basically converging with that area. Now, divergent plates create variety of landforms, including mid-oceanic ridges, right, underneath the oceanic water. That is where, observe, these are your mid-oceanic ridges. This is the divergence of plates. And these are the regions of active volcanism. Many of the times, what also will happen, that as the molten materials, they start coming up. As the molten materials, they start erupting, these molten materials will start to solidify here itself. And sometimes the molten materials, they can pile up and lead to formation of islands as well. How? So for example, let's suppose you have a plate like this. Right? Now, ideally, if we are talking about oceanic areas, this is the region under water. Now, sometimes it also happens that as there is divergence due to the convection current, now here, molten materials might also rise up and they might begin to pile up over this area. Okay, the molten materials might begin to pile up in this area. Eventually, they might emerge above the surface of water, and that will lead to the formation of volcanic islands here also. Formation of volcanic islands. Now, we have also seen that when we talk about divergence in the case of the oceanic areas, in the case of the continental areas, so first of all, as there is divergence, we have seen this earlier also. If I can take you back to that particular image, if I can bring you back to that image, observe, as there is divergence here, as the plates basically are pulled away, they, because of the tension, the central portion which develops the cracks, that central portion, there is nothing holding it together anymore. So you will have formation of depressions or rift valleys. Rift basically represents a kind of a tension. So there is a formation of rift valleys in this case. So for example, observe this. This is a kind of a rift valley. Okay, this is the image of East African rift valleys. Okay, that is the example of East African rift valley, where you will observe that as these plates are moving away from each other, you will find that there is, observe, the middle portion is simply sinking down. Now, this is a very long depression. Don't think about it as a small ditch, because all these tiny whitish structures that you observe, these are well larger structures of homes, right? So 2 to 3 story buildings, many of them they represent. So that is where the entirety of region of East Africa, that is basically moving away from the region of the remaining portion of Africa, because there is a convection current which has emerged underneath the portion of Africa. And as a consequence of that, you have this divergence leading to the formation and creation of rift valleys. So here you have volcanic eruptions also, and across these regions you will find the presence of mid-oceanic ridges. Mid-oceanic ridges become the centers of divergence. It is here where Iceland lies. Observe, Iceland basically is at the divergence point between the regions of Eurasian plate and the North American plate. Here, volcanic eruption has created the island. Okay. We will study later that the kind of volcanic eruption that occurs in this case, that is also what is known as the Icelandic eruption. Here you have another kind of a divergence which is occurring. Pacific plate, and this one is the Nazca plate. Nazca plate. Right. So here basically you will observe that there is a divergence. Now this is also what is referred to as these mid-oceanic ridges up between the Pacific and the Nazca plate, by the way. That is also what is referred to as the East Pacific Rise or the Chilean Rise. Okay. This is what is known as, the name is East Pacific Rise. Pacific Rise or Chilean Rise. Why I have given you this name is, I have not given you other names, is because as of now, the rate of divergence anywhere across the planet is maximum in this area. The rate of divergence is absolute maximum in this area. In this area, plates are diverging at a rate of, currently, plates are diverging at a rate of 15 centimeter per year. Something at a rate with which India was moving millions of years ago, that is happening in between the Pacific plate and the Nazca plate. Observe that here also there is a divergence. Here also there is a divergence consistently. It is the divergence which is happening across this area which is pushing India to collide with the Eurasian plate. Here also you have a divergence. Now, as we speak, for a few 100,000 years in the past, that is for the recent time period of around 500,000 to a million years, there has been an active divergence happening here as well in this area. This is what is also referred to as the East African rift. So what do we mean by this? That means in the near time future of a few million years, you will find that this portion of Africa is going to separate from the rest of the landmass. Let me use another color which is visible. This portion of Africa is going to get separated from the remainder of the portion of the continent, and the remaining portion of Africa is going to collide with the Eurasian landmass. And remember, here you have the Aegean, the Ionian Sea, which is again a remnant of the old ancient Tethyan sea floor. So here again, as Africa will collide with Eurasia, just like we have seen the formation of Himalayas, here also you will find the formation of another mountain range, another fold mountain range, as the rest of the African continent is going to join with Europe. Obviously, in the next 15 to 20 million years is something that you will find this. Okay. Now, in this case, you will find a certain kind of volcanic eruption in the regions of divergence. I want to show you this image of that kind of a volcanic eruption here itself. So, if I can basically show you that volcanic eruption. Here you will observe these kinds of volcanic eruptions, something which is being observed in Iceland. Here in this image, I hope you are able to see this image. In this image, I hope you are able to see that how there is a large crack almost on the ground surface, almost a very large crack. So in these cases, there is a divergence. And this divergence will open up these cracks. And as these cracks will open up, you will have volcanic matter which will start emerging out. That is what is happening in the region of Iceland. These are fissure volcanoes. Fissure, basically, the meaning of fissure is crack. So when we talk about fissure volcanoes, we are talking about a large crack opening up where there shall be volcanic eruption which shall happen. In 1700s, in 1770s, you basically had a volcanic eruption in this region of Iceland. Now that was the what was referred to as the Laki eruption. And during that eruption, you won't believe, but a large crack having a dimension of 37 kilometers. Think about it. From your house, measure any particular distance which is around 37 or 40 kilometers. So that much distance, a 37-kilometer long crack opened up, and you had continuous upwelling of molten materials, upward movement of molten materials. They continued to come up from the surface for many months, and you had these regular movement of volcanic material continuing for a few years. It is said that in the Laki eruption, you had close to around thousands of kilometer cube. Kilometer cube represents volume. Thousands of kilometer cube of molten materials were actually expelled during this Laki eruption in Iceland. So Iceland, that is why, is a center of these kind of volcanic eruptions. And Iceland earns a good amount of money out of volcano tourism, right? Iceland, basically, if you will observe, ever if you want to explore the region of Iceland, they earn out of volcano tourism. They will have their entire theme developed around volcanoes, that we will take you to visit volcanoes or older volcanic areas, etc. So the entirety of the region of Iceland is very active volcanically because it is at a point of divergence between the North American plate on one side and Eurasian plate on the other side. Now, I want you to apply a logic here. So, basically, if you talk about, let's suppose, divergence of plates. So, let's suppose this is a plate, this is another plate. Okay. Now, here, molten materials are trying to come up because there is divergence of plate. Now, generally, the molten materials will come out easily. But sometimes it might happen that the rate of divergence or the rate of movement is not the same as much the molten materials they try to come out. So sometimes here also what you will observe is that the molten materials, they try to come out along with the gases and the liquid, they will continue to hit the landmass. Unless and until the landmass cracks open, they will continue to hit the landmass. So every time that these molten materials come up with a force and hit the landmass, will you experience something on the landmass? Or will that force be too minor for you to experience? What do you think? Will there be a force experienced on the landmass? Yes? Yes. So that is why always in the regions of divergence, sometimes you observe minor earthquakes. And minor earthquakes means basically minor shaking of the land surface, because the molten materials there, they try to hit the surface. So that is why there will be shaking of the landmass as they will come up and hit the surface. This is the reason that the volcano in Iceland erupted yesterday, right? Day before yesterday, basically in the last 1.5 days, that is when the volcanic eruption occurred. But for the past 1 month, Iceland has experienced 800 earthquakes only in the past 1 month. 800 earthquakes, which tells you that the molten materials, they are trying to come up. That is why in the regions of these divergences, when you have too much amount of earthquakes, that is a kind of a symbol or a kind of a signal that molten materials are trying to emerge out of the surface. They are waiting for a crack to open up. That is when evacuations, they begin to happen. Similarly, when we were talking about the convergence of the plates, Remember, in the point of convergences, we talked about the fact that the oceanic, whenever we talk about oceanic continent or oceanic, the oceanic crust goes down, but that movement won't be smooth. That movement will be staggered. Whenever there will be sudden movement, there will be emergence or expulsion of huge amount of energy which will basically shake the earth's surface. We experience that as earthquakes also. But we also know that whenever there is that sudden movement, or there is the movement of the oceanic plate, subduction of the oceanic plate, eventually the oceanic plate will go to a depth. That is when they will start melting. Molten materials will rise as volcanoes. So whenever there are active earthquakes happening in the region, for example, of oceanic convergence, that is always a harbinger or a kind of a foreteller of an idea that volcanic eruptions can happen in the near term future here. Because that means more oceanic plate is going down, it will melt, it will rise up in the next couple of years. For example, if you would have witnessed or noticed the current affairs for the past month, you would have observed that the eastern coast of Philippines, that this entire region around Mariana Trench, that is where a lot of earthquakes have occurred. That means the Pacific Sea floor is undergoing subduction. And that means in the near term future, Philippines, that is in the next 2 to 3 years, Philippines will experience volcanism. In fact, you have no particular, this should not come as a surprise, that basically you have Mount Tal in Philippines already indicating signs of volcanism due to the movement of the Pacific plate. Right. So this is always correlated. Plate movement is always correlated with each other. So that is the case of the divergence of the plates. Then we have the transform plates. What do we mean by transform plates? Transform plates mean when the plates move parallel to each other. Move parallel to each other. Now, will they be able to create new crust, or would they be destroying the older crust? No. So if they are moving parallel to each other, they would neither create a newer crust nor destroy an existing crust. Right is right. So that is why these are also what are known as conservative plate margins. Conservative plate margins. That is, neither create or destroy an existing crust. Now here, again, I want you to apply the same logic. You have the plates which are neither moving towards or against, they are moving parallel. Do one thing. Close the fist of your hands, right, of the palms. Now here, in the corrugation of your fingers, the indention that your fingers have, try to move both of the fist with respect to each other. It is not a smooth movement, is it? There's a resistance that you feel. Imagine the rocks in this case. So as they try to move parallel to each other, there will be a lot of resistance. And they will suddenly, because there is a continuous movement being pushed by the convection current somewhere else, they will eventually be able to overcome that and have a sudden movement. So that will again lead to the shaking of the earth's surface. And that is why here also you will experience very high magnitude earthquakes as they move. So in these areas also, across these plate margins, very high magnitude earthquakes. magnitude earthquakes are basically observed. Very high magnitude earthquakes are observed even in these areas. Now, here, as the plates they try to rub against each other, as the plates they try to move against each other, sometimes what happens is you have cracks which develop here. In these areas, you will have cracks because obviously the rocks, as they're trying to move with respect to each other, the movement won't be smooth. So the rocks develop some cracks. Earthquakes, they center around these cracks. One of these is basically the San Andreas Fault, which is present in the region of California in western part of North America. That is a center of very high magnitude earthquakes. So in this case, the plates move parallel to each other, neither creating or nor destroying a feature. It leads to significant tension being built up and creation of earthquakes and faults. Example, San Andreas Fault in California. Okay, San Andreas and the development of San Andreas Fault in California. Now, here, I have told you that convergence of plates will also have earthquakes, divergence of plates will also have earthquakes, transform movement of plates will also have earthquakes. But all of them won't be of the same magnitude. Apply your logic that in which of the cases the shaking of the earth's surface will be slightly minimum, slightly less. Across width of these plate margins, think about it, take a random guess. The shaking of the earth's surface will be comparatively very less. Very good. Amritansh, Shiva, Godavari, Megha, Debanjan, Githyon, Sarojini, Suaim, Yug Singh, Seema, Vijay Lakshmi, Brajneet, Akash, Krishika, Santosh. Correct. Kittu, Tabassum, Jyoti, Sakshi, Prem Kumar, Mansi, Abdullah, Vikalp. Correct. So, in divergence of plates, the shaking of the surface will be minimum. Why? That is because in those areas, the land is already trying to move away from each other. So, already the existing forces, the land trying to move away from each other, creating less resistance for the volcanic matter to come out. But when we talk about either the transform movement or the convergence, there's a lot of resistance. That is why earthquakes of least magnitude are observed in the regions of divergence of plates. Earthquakes of very high magnitude are observed in the region of convergence and sometimes even transform. Very high magnitude earthquakes. Okay, so that is basically the case of the plate movements. These are your major plates, and this is the plate movement. Use this map for your revision also. Now, I want you to observe these areas. Observe this region. Himalayas, all the way into the region of Jammu Kashmir, Afghanistan, Pakistan, Iran. You would hear frequent news stories about earthquakes rocking in this area. Earthquakes basically dominant in this area. Why? You have convergence of plates. But other than the Himalayan region in India, there is another area in our country which is very frequently experiencing earthquakes, which does experience high magnitude earthquakes very frequently, almost once every 50 or 100 years. There is a very destructive earthquake other than the Himalayan region, which occurs in other part of the country. Can you guess that? Good. Abdullah. Twisha, correct. Prem Kumar, Vibhu, Akash, I'm talking about India, Brajneet, not Pacific Ring of Fire. Sushmit, correct. It is basically the region of Gujarat. You would have heard about the very infamous Bhuj earthquake. Bhuj earthquake literally destroyed the entire area. We had around 10,000 unofficial figures take that number to close around 10,000 people who perished there, right? Large cracks opened up on the ground surface because of the shaking of the earth's surface. So why does Gujarat experience so much amount of earthquake? Because if you take a look at the region of Gujarat, Gujarat lies at the boundary of three plates. Yes. Gujarat lies on the boundary of three plates. And that is Indian plate, Eurasian plate, and which is the other plate? Eurasian plate, and then the minor Arabian plate. So if there is any movement in any of these plates, be it the Indian plate moving northwards or the Eurasian plate coming southwards or the Arabian plate moving, any of these plate movements which happen, and they will happen eventually, isn't it? Massive earthquakes, they rock this area. That is why in 1800s, you see, it was not as if the Bhuj earthquake, which happened in Gujarat in 26th of January 2001, that was the only earthquake. No. In 1800s, in the first decade, couple of decades of 1800s, you had such a massive earthquake happening in the region of Rann of Kutch that you had, as the rocks, they basically moved with respect to each other, the plates, they moved with respect to each other. Think about it. Suppose, imagine if you have one of these plates, another one of these plates, and in between the rocks, obviously the fragment of rocks will be present. So as the plates, they would move, sometimes the rocks get uplifted. So you know what? Many of these earthquakes, they have given a rise or led to a condition where land has come above sea sometimes. And at the same time, you had a massive earthquake in 1819, during which a significant portion of land simply sunk underneath the water because of that earthquake. That is why the region of Gujarat, over the period of hundreds and thousands of years, it has experienced so many devastating earthquakes. Many of the regions have gone under the sea. Many of the regions have emerged over the sea. That is where the entire story that you hear about a kind of a drowned city, a sunken city of Dwarka. You would have heard about it in mythological tales. You would have heard about it if you live in Gujarat, if you have been to Gujarat, there are many stories about the ancient city of Dwarka, which actually went under the sea. That is where those stories they come from. Because Gujarat typically has witnessed that the existing landmass simply sinks. Because as the rocks they try to move, a small rock portion in that adjustment might break from underneath and it sinks, it is consumed. And it can also happen that as these rocks they churn out, some small portion of landmass emerges up. And here observe, again, observe here. There is convergence here. This is the reason why across this entirety of area spreading into Bay of Bengal also, you have significant amount of earthquakes happening in this area. And here, there is convergence in this area. I want you to observe this portion, the region of Andaman Nicobar. Here, the convergence which is happening, what will you classify this convergence in the region of Bay of Bengal? Will that be continental, continental, oceanic, oceanic, or oceanic, continental in the region of Bay of Bengal? What kind of convergence will be there? Oceanic, oceanic, very good. There will be oceanic crust of the portion of Indian plate colliding with the oceanic crust of the minor Burmese plate here. So it is oceanic, oceanic convergence here. Now, in oceanic, oceanic convergence, just think about it. Tell me the kind of landforms which get created during the time of oceanic, oceanic convergence. What are the landforms which get created? Islands, then other than island, trench. Very good. And these islands are volcanic in nature, isn't it? That is why to the east here in the region of Andaman Nicobar, you will find the only active volcano of India. That is the Barren Island volcano to the east of Andamans. And here in the region of the Andaman Nicobar Islands, slightly to the west of it, you will find the minor Andaman Trench also in existence. So, this is the reason why these islands of Andaman Nicobar, if you now take a look at the map sometimes in detail, you will find the shape of Andaman Nicobar Islands across this arc. It is because there convergence is happening. And then this African plate is also breaking into two here. This portion of Africa is going to collide here. Mediterranean Sea, etc., will disappear. But as this Mediterranean is getting converged here and is getting sandwiched between Eurasian plate and African plate, do you recall something similarity to what we have seen in the formation of Himalayas? In the formation of Himalayas, you had the Tethys Sea. Now, when the Tethys Sea was getting subducted, or from both ends it was getting subducted, what happened? Volcanic eruptions happen. That is why southern portion of Italy is dominated by a series of volcanoes. For example, you basically have Stromboli, Mount Etna, volcano, all these various different types of volcanoes and volcanic peaks are observed in the southern portion of Italy. And here again, as the African plate is pushing here, on the margins, you will have formation of fold mountains. Which are these fold mountains known as? What are the fold mountains present here known as? Atlas Mountains. Very good. That is the Atlas Mountain. Here, as there is convergence with the Nazca plate, you have a fold mountain along with volcanic peaks which get created here. What are the name of these mountains? Beautiful. Andes. Here in North America, you have two series of mountains. One is present far away from the coast, and these are known as Rockies. Good. And the one which is absolutely at the coast, which is the youngest fold mountain getting created, what is it known as? The Cascade Ranges. Beautiful. In fact, it was the continental convergence which led to the formation of a mountain range here. Which is the mountain range here? The Ural mountain range. Okay, there is a formation of another fold mountain range here. And what is that mountain range known as? Caucasus. Very good. Alps are again formed due to this convergence. Alps are present here. You have another fold mountains formed as at one point of time this small landmass collided with Europe, and that led to the formation of a mountain chain here in between Spain, Portugal, and the region of France. I had given you for the mapping of that also. What is that known as? No. That is the mountain range. Find it in the atlas. It is Pyrenees. Alps are situated here. These are your Alps. These are your Pyrenees. Here, at one point of time, the North American plate did collide. Before the divergence, it did collide with Eurasia, and that led to the formation of Appalachians here. Okay, and as we speak here, you will observe that there is a crack which is developing in this area to the west of Indonesia. The region of Australia is moving like this, India is moving like this. So the Indo-Australian plate over the next few years is going to break into a separate Indian plate and an Australian plate. Here observe you have the Philippine Sea plate, the Caroline plate. It is underneath these newer oceanic plates that the older Pacific plate is undergoing subduction. And that is why here you will have the Mariana Trench and volcanic peaks such as Mount Pinatubo, Mount Tal, and here observe the region of Japan. That is why experiences volcanism in the form of Mount Fuji and series of very intense and high magnitude earthquakes along with the formation of Japan and Kuril Trench. So that is how I hope you are able to visualize what happens across the world and more importantly, what is going to happen in the future. Okay? Now, then a couple of questions here. Which of the following phenomena might have influenced the evolution of organisms? How is it that evolution of organisms happen? As they adapt to newer conditions. That is how evolution happens. So which of them have influenced the evolution of organisms? Correct. Majority of you are correct. Both 1 and 2. Even glacial cycles, that is frequent existence of ice age and the melting, that has also helped the organisms evolve. Newer species have evolved, and the continental drift as it happened. There also newer climates were exposed, so there also evolution was influenced. Now, which of the following pairs are correctly matched? Here is the theory or the law, and here is the associated scientist. So, continental drift, expansion of universe, photoelectric effect. Which of them are correctly matched? 30 seconds should suffice in this case. This should be easy. I expect many of you to get it correct. Yes. Good. Very good. So, continental drift was provided by Alfred Wagner, incorrectly matched. Expansion of universe was provided by Edwin Hubble, incorrectly matched. Photoelectric effect was provided by Albert Einstein. So this is basically B3 only. Why wouldn't you have done this correctly in the new format? You do know about continental drift and expansion of universe. That would have been sufficient. That only one, even if it is only one option is correct, only two option is correct. And even if you have not studied photoelectric effect right now, wait till you study science and tech, you will basically get an idea about that. Okay. Now, in the structure of the planet Earth, below the mantle, the core is mainly made up of which of the following? This I expect at least 90% of you to get it correct. Please don't disappoint me in this case. This is one of the easier ones. At least 90% of you should get it correct. Because I've given up hope for 100%. So, okay. Chalo, I'll make do with 82% also. I'm an accommodating fellow. So here the correct answer is iron. So that is basically some of the PYQs. And now we move on into the portion of earthquakes, volcanoes, faults, and faults. This is just going to be a kind of a, okay, leaderboard. Right. I understand. So those of you who have got it correct basically would want to see your name in the leaderboard. You get that Kaun Banega Crorepati kind of a feeling, right? So almost all of you have got it correct, and then it is based upon the time taken to get it correct. Okay, so if your name is not there in this list, don't worry, these many of you have got it correct, all three of them. Okay, right? See, those of you who get it incorrect, you are never interested in leaderboard, but when you get it correct, obviously. So basically, now we come to the portion of earthquakes, volcanoes, faults, and faults. For the prelims here, what is going to be relevant is seismic waves. Even this year, you had a question directly picked up from what we talk in the PPT about. So this is one of the areas, basics of P and S waves. Then after that, shadow zone. Then after that, when we talk about, let's suppose, intensity and magnitude of an earthquake, then basics of volcanoes, then after that, the portion of types of magma and lava based on chemical properties. Then after that, intrusive volcanic landforms. Here, generally match the following kind of a question can be asked. That is, name of landform, the shape that they have. Now, this is an area frequented in the mains examination also, both for your GS as well as for your optional. So here, global distribution of earthquakes, global distribution of earthquakes, induced seismicity, shadow zone, first of all, can also be asked. shadow zones, the basic concept, induced seismicity, global distribution of volcanoes, Then after that, you can also have a question associated with, let's suppose, hotspots and mantle plume. It is from these areas that questions have been asked and the questions which can also be asked. Okay. Now, we start first of all with the portion of earthquakes. So, when we talk about earthquakes, what is an earthquake? So, the shaking of the earth's surface, when the earth's surface gets disturbed, it starts shaking up. That is what is an earthquake, right? It can happen because of variety of reasons. It can happen at a variety of depth. But in a nutshell, generally you will observe that energy is released somewhere in the interior. That energy may be of a kind where, let's suppose, the frictional forces are overcome, right? The forces of friction exerted on one as compared to other, let's suppose that might be overcome. That can also lead to an earthquake, right? Sometimes it can happen that in one area the molten material, they are uh, facing a lot of resistance, and that resistance might be overcome. Let's suppose you have plates which are trying to move with respect to each other. We have seen in the case of convergence. Now, initially there will be friction, and suddenly, let's suppose, that friction is overcome. So the point in the interior where that energy is released, that is the origin point of an earthquake. That is what is also referred to as the focus of the earthquake. So when we talk about focus, point in the interior, where energy is released. Force acting interior of planet is called earthquake? Absolutely not. The forces acting from the interior, they are known as endogenic forces. Earthquake is just one of those endogenic forces. I will show you the entire classification of it. So the point in their interior where that energy is released, that is known as the focus of an earthquake. But how do you use that for reference? For example, let's suppose you talk about the, or focus is also the origin of earthquake. Let's suppose earthquake has occurred somewhere in the interior of the zone of convergence between the Eurasian and the Indian plate at a depth of around 60 kilometers, let's suppose. Now, how do you refer to it? That where the earthquake has occurred. What will be your point of reference? So for that, you draw a, basically, you have a point on the ground which is perpendicular to the focus. That is the epicenter. So on the surface, the point immediately above the focus, generally used for referring to the origin of the earthquake on the surface, that is the epicenter. So epicenter is directly above the region of focus. Okay, epicenter, point on the surface above a focus. Okay, that is what we refer to as the epicenter. Now the focus can lie anywhere, wherever, let's suppose there is divergence or convergence, etc. Any point of time there might be a resistance which might be faced and it can be overcome. So depending upon the focus, there is a classification of an earthquake into shallow focus earthquake, shallow focus, where the earthquake occurs at a depth of around 0 to around 100 kilometer. Generally around 0 to 60 kilometer is taken as shallow focus, but in certain classification you will also find 0 to 100 kilometer. Then you have intermediate focus. Now point of intermediate focus is generally at a depth of roughly around 100 to 300 kilometer depth. And then you have deep focus. Deep focus earthquakes, they lie at a depth of around 300 to 700 kilometers. If let's suppose you have a question that why is it that beyond this you don't have the occurrence of or origin of earthquake, is because of the fact that at a depth greater than this, let's suppose there is a kind of tension or a kind of a compression, or let's suppose any friction. At that depth, the temperature is so high and the pressure is so high. Rather than the materials overcoming that friction, they get deformed easily. Right? So if let's suppose a material is trying to go down here and it is unable to move at that depth, it will simply get deformed. So that is why earthquakes beneath the depth of 700 kilometers is never experienced. Now here again apply your common sense. Out of the shallow, intermediate and deep focus earthquake, which is going to cause maximum damage? Which has got the maximum damage causing potential? Beautiful. Very good. It is always going to be shallow focus earthquakes, because in that case the energy has been released very close to the surface. So that will shake the earth's surface very significantly. Always. Okay? So, for example, we have seen the convergence of plates. Now, convergence of plates always will lead to shallow, most of the times will lead to shallow focus earthquakes. Transform plate movement also sometimes lead to very shallow focus earthquakes. But convergence sometimes, as the plates are converging, sometimes the plates will go. Some portion of it might melt in the region of asthenosphere, but as it pushes further, convergence can lead to deep focus earthquakes also in certain areas. Okay. Now, when we talk about an earthquake, basically, you have to understand that our knowledge, our idea about these internal phenomena, that has rapidly accelerated in the past 100 years or 110, 120 years. We have already talked about it, that how 1900s have been the pinnacle of this scientific discovery. Rahim, what is it that you are unable to understand, my dear friend? Sir, थोड़ा explain करके बताइए. Okay. What is it that you are unable to explain? Understand. Let me know. In case you have attended the previous sessions. In the first class, only I put a conditionality that you have to be regular in the sessions. Otherwise, you cannot expect, because you would have understood till now that how each and every class we are basically building up on the previous concept. It is always going to be a build up on the previous concept, and the same logic, the same approach we are going to follow for the rest of the geography. So everything is basically each concept is going to lead to the next chapter. So Raheen, please tell me, which is the portion in which you want me to explain a bit more? Okay. So I'll wait for your answer. Till that point of time, we will move ahead. Why convection current is somewhere causing divergence and somewhere convergence? Isn't it something, Ashish, that we had addressed yesterday about why the plates move? Did you miss out on that? Again, it is a simple thing. If you have a plate here, A, B, look at the annotations. In case you are missing a session, obviously because you would have some very pressing needs, that is why you might be missing a session. Maybe the prime minister or the cabinet minister would have called you up, and it is something that you could not come through. So basically, in that case, before coming to the next session, the minimum that you should do is take a look at the previous one. So here, let's suppose, okay, Ashish, look at it carefully, because I had written it in the annotations of the PPT yesterday. If there is a convection current here between B and C, right? So B and C are going to move away from each other. But what about A and B? So A and B, what kind of movement will be there, Ashish? Please let me know. A and B, will there be convergence, divergence, or transform? Convergence. C and D, what kind of movement will be there? Convergence, divergence, or transform? Convergent. So here you have one convection current which is leading to divergence in these areas, convergence in the other areas. Is that understood now? Right? Let's suppose you have multiple of these plates. If the two plates, they are getting pushed aside, they will basically get smashed somewhere else. Isn't it? Is that making sense? Right? I hope that is making sense. Yes? Okay. Now, Sudeepa, basically, when we talk about the focus of the earthquake, that is where the energy is released. Let's suppose you have the convergence of the plates. Yeah, let's suppose. Now, one plate is going down. Now, it might happen that the resistance is offered or experienced here. It might happen that the resistance is experienced here. It might happen that the resistance is experienced here. Right? Anywhere the resistance might be experienced. And wherever it is overcome, there will be sudden movement and release of energy. If release of energy happens here, shallow focus. Basically, wherever the energy is released, that is the focus. If it happens at a lesser depth, shallow. If it happens in between, intermediate. If it happens at a greater depth, deep focus earthquake. Okay? Right? Now, can we say that divergence movement on seafloor is leading to convergence or shrinking of the Pacific? Yes, it is. Very good, Prem. Energy we mean in earthquake is same as the convection energy? No, no. Not always will the convection current translate into the same amount of movement. Some of that energy, convection current might even be consumed in melting some portions, in basically the volcanic eruption. So it will not always translate. Okay. Then how transform boundaries, how do they occur? This also we had covered yesterday. Why are these doubts emerging today all of a sudden? We have covered it with the help of the map itself. Observe here, we had talked about it that if this is moving, North American plate and the Eurasian plate, they are moving away from each other. The African plate and the region of South American plate are moving away from each other. So it will not always be the case that here also the rate of divergence is the same, here also the rate of divergence is the same. It can happen that the rate of divergence here is less, the rate of divergence here is more. So in this entirety of the area, the plate will experience a kind of a parallel movement, but at different rates. So there will be a crack which will be opened up. That is how transform plates. Is that understood now, Vaibhav? How we will get to know that plates are older or younger? I mean, you want to know, or how do the scientists get to know it? Scientists, they get to know it by studying the rocks and the radiocarbon dating. Why there will be convergence between A and B? Because A is also moving in the direction B is also moving. There is a divergence here. Observe this. There is a divergence here. Divergence is happening because of convection current. So as this convection current is happening, it is pushing the Indian plate here. Does that mean that the Eurasian plate will also be pushed? No. So here Indian plate will be colliding with the Eurasian plate. There is a divergence occurring here in the region of the African plate. The portion of the African plate is getting pushed here. So does that mean that the Eurasian plate will also be pushed along with it? No. If that would have been the case, one convection current would have ruptured the entire planet. There is divergence happening here. There is divergence happening here. So the South American plate is getting pushed here. Here there is a convection, there is a divergence. So here the Nazca plate and the South American plate, they are convergent with each other. Is that digestible, Nikhat? Is that understood or no? Okay, I think it is not understood. I hope you understand. I hope you get the larger picture that when we talk about, or let me take you to this image, which we had seen earlier. If I hope you are aware that if there is divergence here, does not mean that this divergence will be impacting the Indian plate also. Is that the doubt? And please be responsive after you have asked a question. And if I'm addressing the question, be responsive. Okay. Tell me, what is convergent? If there is A and if there is B, if this is colliding with A, won't that be referred to as convergent? Convergent means what? There is a collision. Relative motion is towards each other. Is that understood? Convergence does not always mean that both of them have to be pushed towards each other. But nonetheless, there is convergence here. For example, let's suppose it is in this case, the Pacific plate is getting subducted here. Now, North American plate in this portion is not moving that much, but the Pacific plate is subducting here. What will you call this? If the Pacific plate is getting subducted there and the North American plate stays in its own place, what will you call this? Will you call it divergent or transform or convergent? Convergent, isn't it? Vaibhav, is the rate of speed of both the converging plates same? Why will they be same? Why will be this they be same? It is depending upon where the convection current is released. That convection current so what you are basically postulating and talking about, Weber, is the fact that if this is the planet Earth, if this is the region of, let's suppose, the portion of core, so what you are saying is that convection current in all these places will be of equal densities and equal intensity. Can that be a reality when we are talking about a spherical planet which has a radius of 6,370 kilometers almost. Can you think about it that from all areas, like a flame on the gas, it will emit equal amount of energy? Obviously not. Earth is not a perfect sphere, right? When Rift Valley is created, the water in the picture that's filled is that saline water. Yes, from the nearby sea or the ocean, it fills in. Akash, yes, that is true. So now we move forward. More deeper focus it will go. We will not be able to experience earthquake as it is much deeper. Yes, that is true. Do we have the map based distribution of different convection currents in the interior of Earth? No, because convection current is not always fixed in the same area. Convection current at one point of time drove the region of North America into collision with Eurasia. Or, in fact, sometimes the convection current can change. So, if you are open to it, I will introduce you to another concept, but I'm afraid that it will confuse you beyond your comfort level, and I don't want to do that. There is something which is known as Wilson cycle. Are we aware of the Wilson cycle? There is something which is known as the Wilson cycle. So Tuzo Wilson, who was basically credited with the entirety of much of the formulation of plate tectonic, this is named after Tuzo Wilson. Tuzo Wilson is the guy who basically came up with the name tectonic, which means building. So Tuzo Wilson postulated a theory which tells you that, look, the present day continents or the planet rather, yes, Subadharani, very good. So Wilson cycle basically talks about the fact that the planet every few 100 million years goes through a phase, and it is consistent. And that is every few 100,000 years, or every few 100 million years, you have one supercontinent which gets created. Initially, you had the creation of the landmass. Now, over a period of time, due to convection currents and heat released from interior, the land masses, they keep on getting divided. They keep on getting divided. So as they get divided, you have formation of various different continents. These continents, they move with respect to each other, towards, away from each other. Eventually, after a few 100 million years, again, as they move, it is a sphere. So if, let's suppose, the objects are moving away from each other, eventually it can lead to a collision also. So eventually, again, they will come together and lead to formation of another supercontinent. That supercontinent again can get divided into various different parts due to the convection current. And as it gets divided again, the land masses, they will move away from each other. You will have formation of multiple continents. Again, these continents basically will eventually come together and form another supercontinent. And that again will get divided. This process keeps on repeating across the planet. Till now, based upon the geological evidences, we have seen the formation of three supercontinents. We have the evidence at least of two significantly. The middle one is not so certain, but we have the earliest supercontinent, which was known as Rhodania. That is the name given to the earliest supercontinent. That supercontinent is said to have been broken into multiple different continents which existed for a very long period of time. Species did exist, various species existed on those continents. Rodinia then came together again to form Pangaea. In fact, it is said that in between Rodinia and Pangaea, there was another supercontinent which got created. Pangaea is the most recent or the latest of these supercontinents which got created, right? So, till now, from the portion of continental drift theory, we have initiated the discussion from Pangaea itself. But before Pangaea, also, you had earlier supercontinents which were created and which got divided. And in fact, if you take a detailed look into the history, is that digestible? First of all, it is important to know that. Is that digestible? Can you wrap your head around that imagination? Yes? Good. So basically, that is how the cycle in the planet, it keeps on going. Now, if you take a look at the cycle of life, when life for the first time got introduced underwater, few of the species, they went over land roughly around 600 million years ago. It is said that when they went over land, it was not Pangaea, it was Rodinia at that point of time. Species, they started growing. Many of the species, many of the plants, they emerged. And then you had such significant volcanic activities rocking the entirety of the planet that many of them, they got divided. Many of the species, they went extinct. Again, everything came together. And when Pangaea was created, it was a desert. The interior regions of Pangaea was so very large. Interior regions could never get any rainfall. Life would be restricted into the coastal areas itself. That is when you had the growth of reptiles, lizards. In fact, Atacama Desert has been dry since the time of the formation of Pangaea itself. And then it was at that time when Pangaea was created, that is when eventually you had the dinosaurs. And that is when the Pangaea got divided. Dinosaurs, they split into various continents with no competition, and they dominated the world unlike anything else. So in the next few 100 million years, again, everything will come together and there will be another supercontinent there. That is why when I tell you about the region, let's suppose here, after a few 100 million years, this entire land mass will be one. This entire land mass, Australia will join this area from the side in the region of the Pacific. Australia will join this. And eventually Pacific plate will be consumed. North America and South America will join this here. Again, there will be another supercontinent created, barring Antarctica, which eventually is going to get joined here also. So that is how, again, a third or the fourth supercontinent will get created. Like that, with the help of the convection current, the Earth continues to release its heat from the interior in a continuous manner. Is that understood? Is it possible with continuing cycle, the amount of land keep on decreasing? Newer land also gets created. More volcanic eruption happens. For example, 95 million years ago, you had such a violent spate of volcanic activities that the islands of Caribbean that you see, that got created due to the volcanic eruption, the base lava which emerged across the planet. And that was one of the times when so much amount of volcanic eruption happened. The entire region that we refer to as Deccan Traps in India, that got created, or lava deposits in that region got created because of that. Okay, right? I hope that is understood. It has got nothing to do with Jurassic World. Please don't get that misconception that Jurassic World will tell you about Pangaea and the Rodinia. Okay, so I hope this is understood, and that basically is something which you inculcate. If the two plates are diverging, Vaibhav, you are at the same question after all of this. If the two plates are diverging, is it possible that the plates move in different speed? Obviously, yes, my dear friend. From yesterday, I have been repeating this consistently. As the two, see, at the point of divergence, the speed will be same because it is diverging. So if this is diverging at, so what we say as the speed or the rate of divergence, it is how they are diverging away from each other. When we say rate of convergence, can it be the case that Eurasian plate is converging at a slower rate, Indian plate is converging at a faster rate? No. Indian plate might be moving at a faster rate, but the rate of convergence will be the same. Rate of divergence will be the same. Okay. Yes, Dikshit, it does happen. Ankush, at the Jurassic age, what was Jurassic age was when you had the Pangean structure. Okay. Meanwhile, Mega, survey classified earthquake also based upon the damage causing potential. Yes. So is that a question or do you want to inform the class about it? I hope that is not a question. Okay. So now, when we come to the portion of what is an earthquake, so basically, an earthquake is shaking of the earth's surface. Energy is released from the interior. But we did not have enough amount of information early in the 1900s or in the late 1800s and in the first decade of 1900 to tell us that where that energy is released, what is the amount of energy released, how is the energy traveling. We did not have any clue about it because we did not have any clue about what goes on in the interior. So mankind has always witnessed earthquakes. For example, if you take a look at the earliest records in Nepal, the Nepalese kingdom, they talk about the occurrence of earthquakes in around 1290s, which led to the destruction of one third of the two-third of the entirety of the Nepalese kingdom. So earthquakes have been the case which has been observed for a long period of time. And people would have always measured the earthquake based upon how much damage they see around themselves. Obviously, for a common layman, for a common individual, even today, you ask your parents and grandparents, they will always tell you that, the earthquake which occurred in Assam at that point of time, that led to a lot of destruction. The earthquake which occurred in Kangra caused a lot of destruction. The earthquake which occurred in Bihar caused a lot of destruction. Earthquake in Latur caused a lot of destruction. So always earthquake used to be measured with the help of destruction which would occur, destruction which would be experienced. So on that classification, you had the devising of what is known as Mercalli scale. Now, Mercalli scale basically talked about the destruction potential. You had the classification of earthquake on scales of 1 to 10. Later on, it was modified to 12. That is why it is also known as the modified Mercalli scale. So, when we talk about the Mercalli scale, it talked about classification of the earthquake based upon damage. Damage caused. Okay, based upon the amount of damage which is caused. So that is why, for example, in Mercalli scale, if you had a grade 1 earthquake, that meant that there has been an earthquake, you have not even experienced, you have not even felt it, you didn't even have the sensation of it, it was so very minor, You could not experience it. Grade 2, there was an earthquake which occurred. Maybe there was some amount of materials which started shaking, but you did not experience this. Grade 3, you experienced it. You had the shaking of the electrical equipments, for example, shaking of materials. Grade 4, grade 5, like that. Grade 12, causing absolute amount of destruction, devastation to the maximum level. So that would be the classification. Now, this was referred to as the intensity of an earthquake. Intensity. Intensity of an earthquake. That measures the damage causing potential or the damage caused during an earthquake. But if I ask you, given the amount of knowledge and information that you have about the interior of the planet Earth, if I ask you, just by looking at the damage caused, can we always have an accurate prediction about how much energy is released during an earthquake? Can we have an exact idea looking at the damage that how much energy is released? Obviously, no. Why? Because let's suppose I have an earthquake. I have three different regions, or two different regions, A and B. Right. In A, the earthquake has occurred at a depth of 60 kilometers. It has released some amount of energy. In B, earthquake has occurred at a depth of, let's suppose, 600 kilometers. It has released much amount of energy. But in general, where is it that the damage will be higher, A or B? Where do you think that the damage will be higher? Always A. Because by the time that energy will transmit itself to B, it will be dampened out, it will be diluted. So always the amount of impact, damage will be more at A, right? I hope we align in that. Now, for example, let's suppose in A, you have the presence of weaker structures, mud walls, such kind of housing. In B, you have concrete buildings, concrete walls, reinforced cement concrete, right? Now, here also an earthquake occurs. Here also an earthquake occurs. These are stronger buildings at B. In A, you have weaker buildings. Where will you observe greater amount of damage, A or B? Where do you think? Always at A. You will experience greater amount of damage, isn't it? So, what we are trying to get at is the fact that damage on the surface is not always a true reflection of the amount of energy released during an earthquake. And that is when basically study of the magnitude of earthquake was devised. Now, how do you study the magnitude? How do you study an earthquake? You study that with an equipment that is referred to as a seismograph. Seismograph. So when we talk about a seismograph here, you basically have a condition. Seismograph is just like your ECG machine, where you would have seen the ECG machine. Now you have a kind of paper which comes out of the machine like this, and you have a pen which keeps on moving on that. So it basically keeps on moving like that. Any shaking of the Earth's surface is basically measured by the pen, recording of the pen. Right? Now, how much the pen has moved, what is the carving created, that depicts the energy released, the amplitude of that energy released. That gives you the idea about magnitude. Amplitude of energy released. Amplitude of energy released. So when you have the amplitude that you measure, you get an idea about what was the energy released at the region of the focus. It might not have that much impact somewhere or a greater impact at other place, but now at least you are able to measure the energy. So generally when more energy is released, there is a greater destruction potential, which is probable. So that is where you talk about the magnitude. Magnitude of an earthquake. Of an earthquake basically measures the amount of energy released during an earthquake. Now, this is measured with the help of Richter scale. Here, the damage caused was measured with the help of Mercalli scale. Here, it is measured with the help of Richter scale. Measured by Richter scale. Now, Richter scale is logarithmic in nature. So you would have heard the news stories that an earthquake of magnitude 5.2 has occurred, an earthquake of magnitude 4.6 has occurred, an earthquake of magnitude 6.7 has occurred. You would have come across these news stories. So that tells you the amount of energy released. So an earthquake of magnitude 6, for example, magnitude 6, has 10 times more energy as compared to magnitude 5. Right? So that is how you will observe that an earthquake of magnitude 7 will have 10 times more energy which is released as compared to an earthquake of magnitude 6. Okay? So all the mathematical geniuses that we have, think about it. Earthquake of magnitude 7 has how much more energy as compared to earthquake of magnitude 5? What do you think? Yeah, that is why I asked this question, because I was so very well expecting the answer 20 times. And how you guys get confused in this. Very good. 30 times. So an earthquake of 6 is 10 times more powerful than 5. An earthquake of 7 is 10 times more powerful than 6. So together, It comes out to be 20 times, is it? It comes out to be 100 times. Crack that in your mind. Try to find it how it has come. So, all those who have said, but one of you had said 30 also. So, you need a greater reflection about how did you arrive at the term 30. Think about it, stand in front of the mirror for some moments and reflect on the answer of 30. That how is it that 30 is an answer that you arrived at? And then we will move forward. So, basically, that is the case of earthquake. So there is a scale of measurement of the earthquake. So Mercalli scale represents the intensity of the earthquake. The range is basically in the in between 1 to 12, and Richter scale represents the magnitude of an earthquake. It is expressed in numbers 1 to 10. Okay. Now after that, we talk about basically the amount of energy released by an earthquake called its magnitude can be measured by the amplitude of the seismic waves produced. Okay, right? Yes, Sushmita, that is correct. 10 into 10, yes. Okay, amplitude for any wave, this is the amplitude. This is what is amplitude of a wave. Okay, so let's take a break. Let's be back by and we will continue. A confirmation about the audio, please. If the audio is clear and available, kindly confirm. Thank you. Right. Simran, I haven't attended the last classes due to my exams. Now it seems very difficult. Look at the recordings. Now the recordings of the classes are available to you. So take a look at the recordings. Find some time to go through the previous recordings, and basically in every class we answer questions for almost 45 minutes to 1 hour. So it shouldn't take much time. Try to do it before tomorrow's class. It should be easily understandable. Okay. The most dangerous earthquake. See, how do you define what is dangerous? That also needs to be understood, isn't it? But in terms of magnitude, one of the highest recorded magnitude is what occurred in the region of Chile. That is due to the convergence of the South American and the Nazca plate, where you had a magnitude of 9.5, which was reported. But destruction and damage caused varies from one region to another. Okay. Now we talk about seismic waves. So, when we talk about seismic waves, basically, intensity is measured with the help of the Mercalli scale, with the help of looking at the damage which is caused around. That is how intensity of an earthquake is measured. Okay. So now we come to the portion of seismic waves. So, what are these? So, whenever you have the occurrence of an earthquake, there is substantial amount of energy which is released in the interior. Now, energy always tends to travel in the form of a wave format, and that is what is referred to as seismic waves. This is basically measured with the help of a seismograph. Okay, that is how you generally end up measuring it. So, that is where you have the seismic wave. So, it is of two types. How? So, let's suppose we talk about planet Earth. Now, by the way, if we talk about energy, is energy unidirectional or is energy multidirectional? As in, when energy is released, does it travel only in one direction or does it travel equally in all different directions? What do you think? Is it unidirectional or multidirectional? Very good. Energy is always multidirectional. For example, if you light a bulb, all the areas will get equally lighted around it unless and until you put a certain kind of a reflector or a deflector there. That light will only travel in one direction. If let's suppose you put a speaker, then sound will be transmitted from in all different sides equally, right? So energy is always multidirectional. So let's suppose you have the release of energy here. This is the focus. Now, from focus, energy will be transmitted in all different directions. Now, let's get certain concepts clear here itself. Now, if I ask you this place, so epicenter, I hope we are aware, epicenter will be present here. Let's name this place as E. Epicenter is the place directly above, perpendicular to the region of focus. Now, if I ask you E, and if I name this as A, which will experience that energy on the surface? E or A? We are talking about almost half of the planet Earth here. So, where is it that energy will be more? E or A? Always at E, because it is the closest. That is where the energy will hit closest. By the time that energy travels up till A, maybe it would have diluted so much that A would not even have experienced anything, unless and until you have seismographs in that area. Maybe you don't even experience that. So here you observe that the release of energy happens from the area of focus and it travels through the body of the earth. These seismic waves which travel through the body of the earth, the interior body of the earth, those are known as the body waves. Okay. Now, let's consider the region of E. Let's consider this region of E. Okay. This is your epicenter. Now, from the portion of focus, energy has been released. Now, imagine that this is your entire land surface. This is the portion of E. So, if you have that energy which basically shakes up E, now it won't be the case that only E will vibrate. As E vibrates, the rest of the land surface also vibrates, isn't it? As E vibrates here, there will be impact felt here also, because due to the vibration of the surface, you will have the energy which moves out. Just like, for example, when you throw a stone in water. When you throw a stone in water, only the region where the stone falls, only that is the region which will get disturbed. But that disturbance will travel outwards in all directions, isn't it? That disturbance will travel outwards in all directions. But this disturbance which is traveling in directions, this is happening only on the surface. It is not something which is happening in the interior. So here you have the energy in the region of epicenter. The epicenter is shaken up by the body waves, and then there is a new energy which gets transmitted all over the remainder portion of the body, all the remainder portion of the surface. So the body waves, they will disturb the epicenter. Once the epicenter gets disturbed, the remainder of the portion of the surface will also get disturbed. So here, once you have the epicenter disturbed, you will have a kind of a generation of energy which will travel in the form of wave outwards from the region of epicenter. Those are known as surface waves. So surface waves travel from epicenter outwards. Body waves travel from focus in the interior. Now you have multiple different classifications of these. For example, body waves, you have the classification as P waves, S waves, P star S, then P star G, PR waves, SG waves. You have multiple of that classification, but all of that is not required for your general studies. The basic understanding is required that body waves are basically classified into P waves and S waves. That is the basic classification of the body waves. They are classified into P waves and S waves. Okay, so we'll study that. Then surface waves are also subclassified into R and L waves. That is not very much required also. Sometimes they are also referred to as, in general, as L waves. So we will take a detailed look into that. So first of all, here, when we talk about this, body waves, they will disturb the particles in a certain manner. So body waves, they are classified into P waves and S waves. So when we talk about each one of them, they will end up disturbing the particles accordingly. How much part of optional can be covered through the entirety of GS? So we will be covering many concepts in the portion of climatology, many portions in geomorphology and oceanography, and portion of Indian geography also. So if you are thorough with this, you will have almost half of the coverage of the optional through this, and the remaining portions in certain greater depths you will have to go through. For example, till plate tectonics, we have covered almost what is required even for optional. So in certain other areas such as cycle of degradation, denudation, then the models and the theories provided by Thornbury, provided by Davies, Penck, etc. That is where you have to dig slightly greater in detail. So 50-55% you can cover up till here. Remainder of the portion, based upon the marks distribution I'm talking about, remainder of the portion you have to cover in the optional separately. Now, in the case of P waves and S waves, you have a different classification in terms of how is it that the energy gets transmitted. So here, let's suppose we consider P waves first, and then we will consider S waves. P waves. So P waves are primary waves. Okay. Now, in this case, whenever energy is released, where is the energy released in the case of the body waves? The energy is released from the focus, released from focus. Okay. Now they will end up shaking the particles, influencing the movement of the particles. So let's suppose the particles, this is the focus. Let's assume the particles are arranged like this. Okay. This is the portion which depicts your focus. Now, let's assume that this is the direction in which the wave is moving. The energy is getting transmitted in that direction. So, direction of wave propagation. Direction of wave motion or wave propagation. Now, in this case, as the energy is released, the particles will be disturbed just like how you have the sound waves traveling. So the first particle will go ahead and hit the second one, will disturb the second one, that will disturb the third one, that will disturb the fourth one, and eventually you will have the entirety of it getting disturbed. So the wave will travel in the form of compaction and rarefaction, where you will have particles getting compacted, just like how the sound waves travel. The particles moving away, then the particles coming together again. Now, after some time, these are the areas where the particles will be away. The area which was expanded, that is where the particles will come together. Like that, with the help of expansion and compression, the particles will be moving towards and away each other, right? They will be moving towards and away each other. So in this case, the direction of the wave motion is going to be same as the direction in which the particles are moving. That is the reason why these waves travel very fast. So P waves travel very quickly, as direction of wave motion is the same as the direction of particle movement. particle movement. As the direction of the wave is also moving in the same direction, particles are moving in the same direction also. So that is why these waves are able to travel very, very quickly. Now, what if we consider gaseous or liquid mediums? When we talk about gaseous or liquid mediums, there the particles are spaced further away from each other, right? So if this is the direction of wave propagation, here the first particle will be disturbed like this. That will disturb the space of the second particle. That will disturb the space of the third particle. That will disturb the space of the fourth particle directly. It will interfere in the space of the next particle also. So that is why these particular waves, they are able to travel even through gaseous and liquid mediums when the molecules and the particles are actually far away from each other, because the disturbance is going to hit the other one and that is going to disturb the next one. So that is why, because of the same reason, here you will find P waves are able to travel through gaseous or gaseous mediums. Okay, they are able to travel through the liquid or gaseous mediums. And then you have the S waves. S waves, again, the energy basically is released from the same, uh, when an earthquake is occurring, whenever an earthquake occurs, the energy is released at the focus itself. Now, some of that energy will manage to move the particles like this, some of that energy will manage to move the particles in a different manner. So the same earthquake will release this much amount of energy that it will manage to disturb the particles in a different manner. So one kind of a motion leaves or leads to the surface earlier. Another kind of a motion basically disturbs the particle in a different manner. So let us understand that. For example, in the case of the S waves, similarly, energy getting released from the region of the focus. Here, let's suppose, again, this is the direction of wave motion. This is your focus. Okay. Now, in this case, the particles basically get disturbed like this. The first particle will get disturbed like this. Now, in solid, all the particles are very significantly joined with each other. So when the first particle gets disturbed like this, that will disturb the second one also. That will disturb the third one also. So the second one also gets disturbed. The third one also gets disturbed. The fourth one also gets disturbed. So here, the wave will be moving. Let's suppose the first one gets disturbed here. That will influence the second particle. That will influence the third particle. That will influence the fourth one. Like that, the particle will get disturbed, isn't it? Now, each of these particles, they are moving perpendicular to the direction of the wave propagation. Right, this is your direction of the wave propagation, but each of the particles are moving perpendicular to it. So that is why S waves travel slowly. As the direction of wave motion is perpendicular to the direction of particle movement. Okay, that will be perpendicular to the direction of particle movement. Now, what about gaseous and liquid mediums? So, in the case of gaseous or liquid mediums, the particles will be spaced very far away from each other. Let's suppose this is the direction of wave motion. Here, the first particle is getting disturbed like this. Will it influence the second one? Maybe slightly so. Will it influence the third one? What do you think? No, maybe even slightly so. But by the time of that you reach the fourth one, here it won't travel any further because the particles, so if the particles are spaced further apart, let's suppose the first one is oscillating like this, the second one might not get disturbed. In the case of the P waves, the first one was moving, vibrating like this, so invariably the second particle would also get disturbed. But here in the case of S waves, the first particle is moving like this. Maybe it will disturb the second one slightly and it will dampen out. So here you will observe that because of the same reason, S waves do not travel through liquid or gaseous mediums. Okay, that is why you'll find that basically the P waves or the primary waves, they are able to travel through solid, liquid, and gases. The S waves, they are not able to travel through the liquids and gases. They can travel only through solids because how the particles vibrate. So in the case of S waves, you will have a motion of the particles. Each of the particle will be vibrating like this, and this will be the direction of wave propagation. In the case of P waves, the particle will be compressing, they will be expanding, compressing, and expanding, compressing, and expanding, right? And this is the direction of the particle or the wave propagation. So P waves are the first waves to hit the Earth's surface because they travel with a great speed of around 4.5 to around 13 km per second, sometimes even faster, sometimes slightly slower also. S waves, they arrive generally after the P waves, and these waves are almost 1.7 times slower than the P waves themselves. Okay. Now, P waves, they travel in a linear direction. Observe here. They basically will have a motion of compression, expansion, just like the sound waves. How the sound waves travel, that is how they will travel in a linear direction. S waves, they will form a kind of a sinusoidal curve. So they travel in a transverse direction. They will travel only in solids. These can travel through solid, liquid, as well as gases. Now, this is the reason why you will find that this property is used to devise the early warning systems in the case of earthquakes. Always. For example, we do know that P waves will strike the Earth's surface first because it is faster. S waves, because it is comparatively slower, it will reach the surface maybe at a slightly later point of time. So here, what happens is there is a time window of around 1 minute or 1 to 5 minutes in general between the P and S waves, depending upon where the focus is. But at least 60 seconds to 90 seconds is the time window which is available when you have the P waves and the remainder of the S, P star S, all the waves coming together. So As soon as the P waves they hit, immediately alarms are struck off. And you get that 1 to 2 minute of time window. This is a mechanism which is used quite intensively in the country of Japan. Because Japan is a region, because there is a subduction of Pacific plate. Japan has always experienced very high magnitude earthquakes. And Japan, you know it for a fact that Japan has basically had started developing bullet train networks as early as in the 1960s itself. As early as that point of time, Japan had started developing the bullet train network. Now, you had the previous instances also where in the region of Japan, you had the occurrence of earthquakes. And as the ground was shaking up, the trains basically simply flew off the tracks because the ground was shaking. If you have a high speed train moving on that and the ground is shaking, the train obviously will get derailed and you had casualties. So now, even if you experience very massive earthquakes, which Japan generally does, you will never come across the news story that the bullet train network has experienced casualties. That is because in the region of Japan, now you have this P wave based early warning system, where immediately as the P waves strike, there is an alarm which goes off in the entirety of the network. And as soon as that alarm goes off, you will find a situation, you will find a scenario that almost immediately as the alarm strikes off or goes off, emergency brakes are applied. All the trains within the next 30 seconds they come to a halt. So when the entirety of the rest of the waves, that is, you have multiple different types of body waves, S waves being one of them and the slower amongst them, the rest of the waves, when they will disturb the epicenter, by that point of time the trains would have already come to a halt. And that has managed to reduce casualties quite significantly. On the face of it, you might think about it that 60 seconds is not so much. We should have at least a warning of 2 days so that I could carry my valuables. I could have all the good downloads, whatever I needed in my laptop. So at least 2 days advance notice, if you give me, then I can evacuate possibly well. But if you think about it, that even that 60-second can be very vital for you going to the safer areas, hiding in certain safer regions, coming into an open area, so that the destruction cost is reduced. Destruction will be there. Japan still faces casualties, but the destruction cost is less. So that is how your idea or your knowledge of P and S waves, their basic properties, also helps you in managing various disasters which occur in different areas. Okay. Now, then we come to the surface waves. So when the body waves, they will disturb the surface from the epicenter outwards, just like ripple in water. From the epicenter outwards, the disturbance travels. And this is what causes the downfall of the various buildings, the destruction of the various buildings that you come across. That is what is caused or created. Now, that is generated on the surface, what is known as surface waves. So, when we talk about the surface waves, so let's suppose if we talk about a particular surface on the ground here, let's suppose this is the epicenter. So, as the epicenter is disturbed, energy travels outwards in all different directions. Energy travels outwards in all different directions. Right? It does travel outwards like this. So this is what is going to shake the building standing here. Right? And the buildings basically fall. That is why it is said maximum damage caused during an earthquake is by the generation of the surface waves. If the surface waves would not have hit, if the surface waves don't spread outwards, then the damage caused is comparatively less. So surface waves are those waves that travel on the surface of the earth. Destruction caused by earthquakes is primarily done by these waves. On the basis of their nature of movement, they are further classified into two categories: L waves and R waves. Love waves, these are also known as L waves. These are also what are known as R waves. If you have to take a look at the comparative speed, P is the fastest, then the motion of the S wave is comparatively slower. Surface waves, they travel with the least amount of speed. Now here, what is the basis on which you have the classification as love wave or Rayleigh wave? Based upon how the ground is disturbed. So the ground can either be disturbed horizontally, like this, the shaking happens like this, or the shaking can happen like this. So based upon that, how that disturbance occurs, in the case of love wave, you will observe a kind of a horizontal vibration of the ground surface. A kind of a horizontal vibration of ground surface is experienced. So that is where the buildings, they are basically shaken up. Then you have the Rayleigh waves, which shake the ground surface like this, right? Just like ripples. So that is basically the case of love waves and Rayleigh waves. I understand even if you don't have a question right now, many of you will have that and ask that question, why the name love waves? So basically, see, I already have a question. Why the name love waves? It is not because of whatever you might think. It is because named after the scientist Alex Love. So it is based upon the scientist name. It has got nothing to do with romance, nothing to do with the ideas floating in your head that this wave creates a good scenario all around. It has got nothing to do with that. And already I was not mistaken. I have a couple of questions why the name is love. So I hope now that curiosity is quenched. Okay, that why the name, it is based upon the scientist name. Okay, right? And sorry to disappoint you in that case, all those who were basically looking forward to a kind of a romantic story behind it, that love blossomed when you had these kind of shaking of the ground surface. So sorry to disappoint you in this. It is very straightforward and boring explanation for that. Okay, now that is the case of the surface and the body waves. Then we come to the concept of shadow zones. So, before we come to the concept of shadow zones, here we talk about the body waves for a brief bit. Yes, Anjan, that is correct. Yes, Tanishta. So, here, if we talk about the body waves, they are emitted from the focus outwards. They will travel in all direction. You know, every day, the planet experiences more than 100 earthquakes. More than 100 earthquakes, almost on an average, take place on a daily basis. Not all of them are of such great magnitude that they will impact the surface or which will be felt by us. Many of them can be felt only with the help of seismographs, right? So with that, the seismographs are basically placed all across the entirety of planet earth. With the help of the various observatories that you have these seismographs which end up measuring even the slightest of the variation. So with the help of the network of these seismographs, you are able to measure out what is the path taken by the seismic waves, how they have traveled, and that gives you an idea about which region they have traveled through, what is the time taken for them to travel, and by that you can extrapolate what is the interior structure in a particular area. So here, when we talk about the body waves, as the body waves are moving from here to here, will it be correct to assume that they move through materials of different density? Or will that be an incorrect assumption? What do you think? As the body waves they travel from one region to another, will it be correct to assume that they travel through materials of different density, or do they travel through materials of the same density? Different density? Perfect. Now, what happens when waves they travel through materials of different density? You would have studied the concept of refraction sometime in your previous life, because many of you won't be remembering it now. So it would be correct to assume that sometime in the previous life you would have studied that. Yes, refraction, where you would have seen this, that if you have glass or water, as light falls on this, it encounters material of different density. There's a slight change in direction. And then again, when there is a change in direction, the light actually deviates, right? Okay. So this brings me to the first conclusion, which I will point out to you for the next 15 minutes continuously, because I'm sure that will be required. So that is, as waves travel through materials of different density, of different density, speed changes. As the speed changes, the waves undergo a bend. So that brings me to the corollary, or another implied conclusion, that body waves, when traveling through interior, will bend. Comfortable up till this point? Right? Comfortable? Any of you getting the idea that we are going into rocket science? Now is the time to ask. Comfortable with this? Good. Bending how? Yes, I was aware of this. How that is bending. So, when light basically moves like this, are we aware that the light bends when it goes through the glass or water? You would have seen that at the depth of water, materials they start appearing shallower. If you look at it from above, the bottom of your bucket appears shallower. Abhay, have you noticed that? It is actually deeper, but it appears shallower. Where are you going into critical angle concept, Ankush? If we are having difficulty understanding the aspect of bending. Abhay, are we aware about the concept of refraction? No? Okay. So in that case, if we are not aware about refraction, just take it as a norm of life that this happens naturally, because I don't want to go into the detail of refraction, that as the light travels, it, let's suppose in air it is having lesser density, so the light is able to travel in a path. As it enters the region of the glass, it encounters a material of greater density, then its speed will reduce, so it will slightly move with a slower speed. Again, it moves through the air. That is where it will again move through a faster speed because it is of less density. Why? Okay. Okay. So, Abhay, in that case, kindly take up the basic book of physics or the basic sciences of class. I think it would be taught in class 7th or 8th, right? I'm not sure about the syllabus distribution as of now, but ninth or 10th, yes, 8th or 10th concept. Abhay, do you remember? Okay, understood. Okay, fair enough. Good. So just understand that the waves, as they body waves, they travel through the interior, they experience a bending. Why? Because in the interior, we are well aware of the fact that there is going to be materials of different densities, isn't it? How different densities? So let's suppose we talk about the interior. You will have the condition where we have seen with the help of discontinuities also, isn't it? That you have crust is different density, mantle is different density. We have seen in that case also. Do you recall that we have different level of various different densities in the interior as it is present, right? So if let's suppose a focus of the earthquake is here, the energy waves as they travel, they will encounter materials of different density, rare medium, denser medium. That will happen. So the waves, they will bend accordingly. I hope we are comfortable till here. Good. So the P waves and the S waves, they also bend accordingly. They also indicate a bend. So let's suppose the focus of the earthquake is here. The body waves will get transmitted in all different directions. All different directions is where the body waves will move. Now here, observe there is a gradual bending here. Now here the body waves will encounter the outer core. This is your outer core. Outer core, that is liquid. So here there will be deviation. Here there will be deviation. Right? There will be deviation. Isn't it? Meanwhile, the waves will also encounter a solid inner core where they will simply speed through. So here also P waves will be recorded. But because of this bending and the various materials that it encounters, you won't have P waves which will be detected in this zone. I will repeat. As the waves they travel through the interior, they will bend in different manner and different direction based upon the materials that they encounter. But eventually, there shall be certain areas where due to the natural bending of the P waves, you won't be able to detect any P wave. Generally, it is at an angle of 105 to 145 degree from focus on either sides. So these are the areas where no direct P waves can be detected because of the natural bending of the waves. Something similar is observed across S wave also. S wave is also emitted. Now these S waves, they will also bend, right? But here, as soon as they encounter the region of outer core, what happens? They will encounter the liquid, molten material. As they encounter the molten material, then what happens? Basically, they won't, S waves we have seen, they cannot travel through liquid. So here the S waves will disappear, right? Regardless of the fact that inner core is in solid state. But in order to reach the inner core, you have to cross through the liquid outer core, but S waves cannot do that. So in this entirety of the area, no direct S waves can be detected. That is generally 105 degrees on either side of the focus. No S waves can be detected. So those areas where P waves and S waves, they cannot be detected because of their natural bending and the different densities in the interior of the planet, those are known as the shadow zones of the seismic waves. You have the shadow zone created by the P wave as well as a shadow zone created by the S wave. Okay. Now, we can also have the conclusion. So, shadow zone, those areas where the seismic waves cannot be detected due to natural bending and materials of different densities they are known as shadow zones. So, when we talk about the shadow zone of the P wave shadow zone, it extends from where to where? Generally 103 and 105, so 105 degrees to 145 degrees on both sides of focus. S wave shadow zone is basically 105 degrees to 105 degrees on either sides of focus. So whose shadow zone is larger, P wave or S wave? Whose shadow zone is larger? S wave. And what is the reason for the larger shadow zone of the S wave? If it is asked in the examination, why is it that the shadow zone of S waves is larger? Because S waves cannot travel through liquid medium and outer core is in liquid. So that is where it cannot pass through the region of outer core. Okay? Yes, Shweta. 105 degree, 105 degree, because on either sides, that is where you won't be able to detect. Okay. Now, please don't get the interpretation of it that in these region earthquakes cannot be detected. Earthquake you won't be able to detect here also, unless and until you have a seismograph. Earthquake you won't be able to feel here also. It is how the body waves will travel. So body waves are you able to detect or not? Okay. Now these body waves, as they travel through the interior of the planet, let's suppose you have an instrument measurement here. You have an instrument of measurement here, here. Now, each of these seismographs will give you some recordings that, okay, this is the amount of shaking. Now, by interpolation and extrapolation of all that data from across the world, that is how you come to a conclusion that earthquake had a focus at 60 kilometers below, let's suppose, Kathmandu, and the magnitude was 7.8 or 8.2. right? Now, remember, we had discussed about Lehman discontinuity. Do you recall where Lehman discontinuity is present? Any of us? Very good. Rohit. Godavari. No, Godavari incorrect. Ankit, Vibhu, Weber, correct. Krishika. So basically, Lehman discontinuity is the discontinuity name given to between outer and inner core. It was Lehman who basically discovered that the P waves suddenly appear to have accelerated as they travel through the region of the core. So he was convinced that there must be a zone within the core which should have such high density that the P waves, rather than slowing down, they are accelerating further. And that is when the conclusion was arrived at that, you know what, in between the molten portion of outer core, you have the dense solid inner core, which despite the high temperature continues to remain in a solid state. That is why, based upon his findings and his discovery that inner core was solid, that is why the discontinuity separating outer and inner core is known as Lehman discontinuity. And on a slightly lesser known aspect, this information is used to basically understand what is the material density mineral present in the interior. Because as these P waves, S waves travel, how their speed changes, that gives an idea about the density of materials in a region. With that, the geologists are able to detect that, okay, nickel might be present here, magnesium might be dominant here, because all the materials have different densities, isn't it? So that is basically why you are and how you are able to detect the interior structure, mineral present. For example, let's suppose in certain areas you have, in the interior portion, you have a lot of water. Now, that also can be detected. In certain area, let's suppose you have a lot of magma buildup. There also, because magma means molten materials, S waves won't be able to travel. You will be able to detect with the help of the P waves. Now, this is also, by the way, used in order to detect. So, have you ever wondered that why is it so that when India launched a nuclear test, when is it that India carried out the nuclear test last? Are we aware of that? Yes, Mohammed, that is correct. 1998. Good. So, have you ever wondered how is it that when a country carries out a nuclear test, someone sitting in US is able to say that it is a nuclear test based upon the seismographical readings, right? Because the seismograph shakes in a certain manner. That is how, because that is how you are also able to detect whether it is an earthquake or whether it is a kind of a blast, a man made experiment. So, for example, let's suppose if you have an earthquake, the seismograph readings will be somewhat different. In case of an earthquake, you will have slight adjustment of rocks earlier, main earthquake will occur, and later on, again, maybe minor adjustment of rocks will happen, right? So these are what are foreshocks which occur before the main earthquake. These are what are known as, this is the main earthquake, and these are what are known as aftershocks. Okay, but if you carry out a major blast, kind of an artificial one, seismograph will also record that, but it will be an isolated event, isolated variation. in seismograph. Okay. That is why when North Korea carries out a missile test, everybody across the world is able to detect whether it was nuclear or not. That is why last year you would have seen the case where Russia carried out one of the detonations of a very powerful bomb. The world was almost convinced that it was a nuclear explosion. But then eventually it was found out that it was not. Russia said that it was just a powerful non-nuclear bomb that we tested. It was during the Cold War era. If you are interested in that spy games, basically there are multiple books about it. It was in the Cold War era where USSR and US, both of them were suspicious about each other's activities, and both of them could carry out nuclear explosions in secret. That is when you had the CIA installing, along with MI6, the British Secret Service agency. They went ahead and they installed the seismographs and recording stations at the height of the Himalayas. In fact, the CIA also collaborated with the Intelligence Bureau in India to install such seismographs in the region around Nanda Devi. That was a secretive mission, which was the earliest known cases of collaboration with CIA. Similarly, it was done in the peaks of Afghanistan also and Central Asia also. Secretive missions were carried out by MI6 in order to understand that if there is any shaking of the Earth's surface, we should be able to detect it. In order to understand what is the intensity of the bomb, what is the power of the bomb that they are testing. So that is basically how the interior of the Earth behaves when that energy travels. I hope this is understood. Now, then we come to what is referred to as a tsunami. What is a tsunami? So, tsunami is a Japanese term which means giant wave. Now, before that, a simple customary question. If I ask you, if let's suppose this is the ground surface, or if this is the land surface, let's suppose, here you have the oceanic bottom, and here you have the water, let's suppose. Right? Now, if I ask you, out of A and B, what will you consider as the surface of planet Earth in terms of earthquakes and seismicity? Very good. So here, A will be considered to be the surface, not B. B is the surface of water, right? So if water is not there, maybe if you will have only the oceanic bottom, still this will be the surface. So this is your surface in that case. Okay. Now, whenever you have underwater earthquakes, in situations whenever you have underwater earthquakes, underwater earthquakes, whenever. Now, these underwater earthquakes, let's suppose from here, this is your focus, energy is released, body waves, they will disturb the bottom. From here, you will have the surface waves which will be generated. Both Love and Rayleigh waves will be generated. So imagine if you have a bucket of water or a mug full of water or any jar of water, without touching the surface, if you simply hit the base, water will always spill over. Always the water will get disturbed. So here also, the bottom of the sea floor, whenever it starts shaking because of an earthquake, what will happen to the surface water? Surface water will also get disturbed always. So that leads to generation of an extraordinary large disturbance above water, and that travels outwards in all directions. Extraordinarily large disturbance on the surface of water, which travels outwards in all directions. And that is what is experienced as tsunami. So, underwater earthquakes disturb the sea floor, generates large waves on the oceans or seas. This is known as a tsunami. So, whenever a powerful underwater earthquake occurs, tsunami warning is issued. Okay. For example, in the region of Japan, you had a massive earthquake which occurred, which led to the Fukushima nuclear disaster as well. Are we aware when that earthquake occurred on the coast of Japan? No? Okay. Yes. It was basically March 2011. So that is when, due to the subduction of the Pacific plate, you had a massive underwater earthquake which generated a tsunami which destroyed the coastal areas of Japan. Now, the tsunami was initiated due to the earthquake. Earthquake was initiated due to what happened in the region of the Pacific. Okay. Similarly, if you wind the clock backwards, on 26th of December 2004, you had a massive earthquake which occurred in the region of western portion of Indonesia, in the region of Sumatra, near the Sunda Trench. You had an earthquake of magnitude 8, which occurred underwater, that generated a tsunami, which destroyed the eastern coast of India, the region of Sri Lanka, Maldives, Andaman Nicobar, Southeast Asia. They were devastated. Then, for example, when we talk about, let's suppose, the case of even as late as 15th of January 2022, that is last year, early last year, you had a huge volcanic eruption in the region of southern Pacific, that is the Hunga Tonga Hunga Hapai eruption. Now, when that eruption occurred, the power released was so very high, such immense amount of power was and energy was released, generated a tsunami which traveled the entirety of the Pacific, and it claimed 2 casualties of the coast of Ecuador. When you had the massive Krakatau eruption which occurred in the 1880s off the coast of Indonesia, that again generated a tsunami so powerful enough, it destroyed many of the regions of South Asia. So, as recently as this month, early this month itself, that is 10 days back, you had a massive earthquake to the eastern part of Philippines. In one of the islands around Mindanao province of Philippines, you had an earthquake of magnitude around 7.2. Immediately, tsunami warnings were issued, but their tsunami did not occur. So that is how the tsunamis generally are observed. Okay. Now, That is the case of tsunami. Now we come to the global distribution of earthquakes. So where do earthquakes occur? Where is it that the earthquakes occur? Payal, what is it that you have not understood? You have to pinpoint that. Okay. I won't go for the fact that explain the entire thing again when we are still explaining it. Now, here, when we talk about geographical distribution of earthquakes, where do earthquakes occur? Generally, when we talk about earthquakes, they will occur somewhere across the region of the plate boundaries, isn't it? Either at the region of convergences, the region of divergence, or the region of transform plate, or also in areas of volcanic eruption as the molten material that it tries to come up and it does not eventually manage to come up. There also, right? Sometimes even across the fault lines and cracks where you have a large fault line, it is not a plate boundary, but respective movement of rocks can also trigger earthquakes, isn't it? So earthquakes overall can occur in the region of plate boundaries, across fault lines. Right. So these are the areas, volcanic regions. So these are the areas where the earthquakes will generally end up occurring, isn't it? So global distribution of earthquakes, if you will observe, there are two such zones, large zones, where majority of the earthquakes are concentrated around. One is the circum-Pacific around the Ring of Fire, and the other is the Mediterranean Asia, the Himalayan Alpine belt, as it is referred to. So observe, when I say these two zones, when we refer to these two zones, one is the region around the entirety of the Pacific, including the Caribbean islands, the entirety of the region around the Pacific. That is one of the area. Then major earthquakes are also observed in the region of Mediterranean, Iran, Middle East, West Asia, Himalayan belt, extending all the way to the region of the Sunda plate also. These are the areas where major earthquakes are concentrated about. The Tonga eruption that I keep on talking about, this happened here. And the tsunami which was generated traveled all the way and claimed casualties here. So you can imagine the energy released even during a volcanic eruption. You know, the Tonga eruption which occurred here, Indian Meteorological Department has got an atmospheric measuring pressure measuring system here. The impact due to the eruption could be felt in the region of Goa, and the disturbance created by that traveled the entirety of the planet twice. So that is the power released. So these are the zones of major earthquakes. Minor earthquakes are also observed across divergence. These are the plates of regions of divergence. This is your transform movement. Here also you have transform movement in this area. So when you have a question which is framed, where is it that you have major earthquakes which are observed or discuss about the global distribution of earthquakes? Always the answer should be that earthquakes are generally observed across areas of the plate boundaries, active fault lines, and also across active volcanic areas. However, the plate boundaries are the dominant regions of the earthquakes experienced. Globally, earthquakes can be distributed or divided into different types, or the regions can be divided into types based upon the amount or the frequency of earthquakes observed. Highest frequency of earthquakes are observed across the circum-Pacific earthquake belt and the Mediterranean Asia Himalayan region. Here you have convergences. What kind of convergences? Oceanic, 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 continental, continental, continental. All these you can elaborate and get good marks. If you have a 250 worded answer which is required, there you can also talk about that in certain areas of divergences also minor earthquakes are observed because of the volcanic material or magmatic material trying to emerge out of the surface and disturbing the surface in the process. So that also you can talk about. Okay. Yes, East Australian coast also got impacted by tsunami, but there, because you have the coral reefs, they form a kind of a buffer, and that is where the coral reefs, they dilute the impact of the tsunami. That is why the eastern portion of Australia was not impacted by the tsunami. Okay. Now, then these are also the regions which we will study later as the zones where volcanic eruptions they occur quite frequently. Okay, this is where you have the Tonga eruption. Okay, so these are the zones of oceanic convergences. All these are the zones of oceanic convergences. Oceanic convergences will occur. Only oceanic convergences will lead to the volcanic eruptions, or divergence, obviously. Amongst convergences, only oceanic convergence will lead to volcanic eruption. We'll study about it. Then when we come to the earthquake zones of India, in India, the regions which are very prone to earthquakes and seismic activities are spread across the northern area all the way to the east. That is the earthquake zonation, and also the region of Gujarat. Now, in the northern and the eastern part, it is because of convergence, continental convergence, which is happening. This has been the zone of very high magnitude earthquakes. The very infamous Darbhanga earthquake in Bihar, which occurred in 1934. Now, there, a lot of lives, more than 10,000 lives at that point of time, were claimed. Now, the earthquake was so intense at that point of time. Imagine Just imagine the scale of disturbance. It is said that the earthquake had a magnitude of around 7.8 to around somewhere 7.89 to around 8. The shaking of the crustal surface was so much. And this is a zone, northern Bihar, Uttar Pradesh, eastern Uttar Pradesh, West Bengal. This is a zone which is made up of sedimentary soil, right? Soil deposits brought by the rivers, that is what constitutes it. The crustal variation and vibration was so much, groundwater started coming out from many of the cracks which opened up on the surface. And many areas, they experienced massive wide scale flooding. So imagine, even today, you won't find very intense or very close buildings in this region, or very high altitude buildings in this region. You won't find there high storied buildings, etc. That is not to be found in the northern portion of Bihar. So you can imagine that around 1 century back, 90 years back, what would have been the situation? Obviously, all the thatched houses, single storied structures. Still, at that point of time, around more than 10,000 lives were lost in that area. Then you have the Kangra earthquake, right? In Jammu Kashmir, you have many of such instances. Gujarat, many such instances. So there is a zonation of earthquake dependent upon what is the expected amount of intensity or damage that is expected. Based upon that, it is divided on the category of zone 2 to zone 5. Okay, zone 5 and zone 4 areas, these are the regions of high amount of rock compression where the probability and the frequency of earthquake is very high. Also, the intensity of the earthquake will be very high. In the region of Assam plains also, very frequent occurrence of earthquakes. But here, let me also tell you that it is in this region where the compression of the rocks is much greater as compared to this entire, on an average. This is the area where the rocks have been compressed very significantly. So the northeastern region is expected to experience much high magnitude earthquakes in the coming decades. Within the next 100 years, it is said that it will take 3 to 4 earthquakes of magnitude around 8 and above for the rocks to release their tension. Right? So basically, same is the case in certain pockets of the Western Himalayas also, where very high magnitude earthquakes are expected in the near term future because the rocks are so very compressed. That is why it is never advisable to go for significant building or construction activities, slope destruction in the mountainous areas, because it can have disastrous consequences if, let's suppose, an earthquake strikes. That is why construction of large dams in those areas is never advisable. Having said that, India has started constructing dams in this area of Arunachal because that is the region where you have significant amount of hydroelectric power potential generation. Okay. Now here we talk about induced seismicity or induced earthquakes, which are basically the kind of earthquakes which are generated due to human activities or anthropogenic activities. So, anthropogenic activities. Okay. Now, this is basically that due to the human activities, you sometimes have the occurrence of earthquake. For example, those of you living in the mining towns of the country, you would have experienced that every now and then there is a controlled blast which is done. Dynamites and TNT that is fixed in the rocks. In order to loosen the rocks, you carry out a controlled explosion, right? So that the rocks basically get loosened off and then you can extract the minerals, right? So, all of you in the region of the mining towns of the country, so every day, almost twice or thrice, this activity is done. Whenever that controlled blasting is done, there is slight shaking. So that is again shaking of the earth's surface. Weaker buildings sometimes they develop cracks. So that shaking, isn't it? So here, controlled explosion. Explosion. Then dams, building of dams. This also leads to earthquakes. How? Famous example, Koyna earthquake. Koyna earthquake. That is basically also when a big truck goes, we slightly feel vibration. That is true. But please don't write that in the case of an earthquake. Last night, yes, last night, China experienced one of the most massive earthquakes in its recent decades and observe the kind of destruction and devastation caused. That is because, again, because of the convergence of Indian and the Eurasian plate. I hope you are following the news story about what is happening in China, right? Are we following what is happening in China or are we bereft of it? Have we like given up? Okay, we are still in Turkey. Okay, Turkey also earthquake happened because of the movement of the Anatolian plate with respect to the Arabian plate. But that happened a long time back, my dear friend. Yesterday night, China experienced a very massive earthquake. Many casualties happened, but we don't know that how much amount of it will be reported in the region in the media, because China is very good at hiding the numbers. So if let's suppose 2,000 will die or 20,000 will die, China will say that 200 people died. So that is the case. And the impact that you felt in the region of Kashmir was also because of that variation and vibration because of that kind of an earthquake. So here, the dams. So when you talk about the dams, now in the case of dams, here, how do you construct the dam? Generally, you would have observed that dams are constructed in the hilly areas so that you have natural reservoir in which water can be stored, concrete dam structure, concrete dam structure, and here you have water which is filled up, the reservoir. Right? Now, all of this will impose a very large weight on the ground surface. This concrete dam, the concrete structure, the reservoir, it will always impose a very heavy weight on the ground surface, thousands of tons in the same concentrated area. Fair enough? Many of the time, what happens is it leads to development of cracks within the rocks due to the weight. It leads to development of cracks in the rocks. Now then, as these cracks intensify due to the weight, now because there is so much amount of water which is stored, that water starts going through here. Slowly and steadily, that water starts pushing through. Now within these cracks, as water gets filled up, can we say that as the rocks are getting compressed due to the weight, and in between the cracks there is water, there will be easy slippage of the rocks. The rocks will always want to release that huge pressure. So because of that water which has now gone in, water will act as a kind of a lubricant, we can say that. So there will be an easy slippage there, isn't it? So that leads to the earthquake. So that is where this can lead to a kind of an induced earthquake. So you have pressure, huge pressure exerted on rocks, leads to development of cracks, movement occurs. Whenever you have the movement of rocks, in the interior, if you have movement of rocks, what will happen? Won't there be the shaking of the earth's surface? That is an earthquake. Whenever, let's suppose, the rocks are deformed or compressed so significantly, the rocks will try to regain their natural position. There will be shaking of the earth's surface. That is what is also known as RIS, or reservoir induced seismicity. That this seismicity is caused because of the construction and the storage of water in the reservoir. Then earthquakes are also experienced due to hydrocarbon extraction during the time of hydrocarbon extraction. Sometimes that is extraction of today's webinar also. So congratulations. I mean, what am I supposed? Okay, you want the class to? Okay, fair enough. After this, I'll end the class. I thought this is an information that you're giving me. Extraction of crude oil and natural gas. Now, where is it that oil and gas is present? Basically, if you take a look at it, so on this, in the case of oil and gas, generally the extraction happens is that it is trapped in the interior layer in the permeable rocks. Within the rocks, oil and the layer of the rocks, oil and gas is trapped there. Right. Now, how do you extract it? How is it that it is extracted? Basically, you bring it pipes. You install pipes. Okay. And through one of the pipes, let's suppose there is so much, there is oil and gas which is present here. Not always will it start coming out naturally. It has to be brought out. So how do you bring that out? So you basically put in high pressured air and water through one end. High pressure, air and water. Now what it does, high pressured air and water, that will start providing that pressure here, and there is only one thin exit way. So that is when oftentimes so much amount of oil and gas tries to rush in through that exit. This is your exit. So oftentimes so much amount of oil and gas tries to rush out. It leads to a blast also sometimes. And in most of the cases, while it is rushing out, it will lead to the shaking of the Earth's surface. So even during oil exploration and oil extraction, you do experience this induced seismicity. Okay. Fractional distillation, my innocent friend, is how you refine the crude oil. Fractional distillation is not how you extract oil from the interior, right? Dams lead to low magnitude earthquakes. So that is where we'll restrict the session here. You have the webinar also. So we will continue tomorrow from the portion of volcanoes. Is there something like induced tsunami or volcanic eruptions? No. Which should I take the subscription of Hindu newspaper or the e-business line? Obviously, new e-newspaper. Please don't take the subscription for e-business line. What will you do? Do you want to become the economist par excellence? In economics, basic questions are asked based upon current affairs. 2 or 3 variations here or there will be there based on current affairs, but basic economics are asked. So just go for the basic Hindu. Be regular in Hindu. Otherwise, there is no end to it. You will be studying economic times also, business standard also. You will end up spending so much time in that. The Nobody is going to ask in the examination in greater detail that explain why is it that the yield rate of the bond market is like that. That questions are not asked. So get your priorities straight. Okay, how mining operation impacts an earthquake? Because when you have mining operations, controlled explosions are carried out in order to loosen the rocks. Whenever that explosion is carried out, it will shake the surface. Okay, and if rocks and oil extraction from rocks, then rocks can collapse or sink. Yes. What kind of webinarticulate do we have? Newspaper? No, webinar you have. I think it is the portion of current affairs associated with art and culture. You can. Ankush, study the basic Hindu newspaper. That should suffice. Hindu also has the business page. That should suffice. That should be sufficient. Richter scale is placed on the surface. Yes. Yes, Seema. Hindu and the magazine is sufficient for correct. See, you have limited time. It is, if you have a 5-year plan in front of you, I would tell you to study economic times also. I would tell you to study Hindu also. I'll tell you to study Indian Express also. You have limited time. So basically, utilize that. Shruti, yes. Along with the discussions that we have, the information in the mains and the additional reading materials, more than sufficient. So that is where we'll restrict the session here today. Yes, Vaibhav, that is more than enough. We meet again tomorrow. Please do revise the portions and we carry out the discussion tomorrow. Thank you. Goodbye. Have a good night.